So students, now let's start activity 1.2 equivalence relation. Our objective for this activity is to verify that the relation R in the set L of all lines in a plane defined by R equals to Lm such that L is parallel to M is an equivalence relation. So students, now let's start the method of construction for the given activity. First, take a drawing board. Place it on a table and fix a graph paper sheet on it. So take a drawing board, place it on a table and fix a graph paper sheet on it. On the graph paper, draw 3 straight lines in such a way that the lines are parallel to each other. That the lines are parallel to each other. And name them L1, L2 and L3. And 2 straight lines perpendicular to these lines, and some are inclined lines. So on the graph paper, draw 3 straight lines in such a way that the lines are parallel to each other and name them L1, L2 and L3, and 2 straight lines perpendicular to these lines and some are inclined lines. Step 3. Name the perpendicular lines as M1 and M2. And inclined line as N1. So students, you can see here the 3 lines L1, L2 and L3. The 3 lines are parallel to each other and 2 perpendicular lines M1 and M2 and an inclined line, that is N1. Now let's see the observation and conclusion for the given activity. First, since every line is parallel to itself, so the relation R equals to L, M such that L is parallel to M. L, M such that L is parallel to M is a reflexive relation. By construction, second observation is by construction we observe that L1 is parallel to L2 and L2 is parallel to L1, which implies L1, L2 belongs to R and L2, L1 belongs to R. Hence, the relation R is symmetric. By construction, we observe that L1 is parallel to L2, L1 is parallel to L2 and L2 is parallel to L1. Hence, it implies L1, L2 belongs to R, that is relation R, and L2, L1 belongs to relation R. Hence, the relation R is symmetric. So, our third observation is, similarly, we observe that L1 is parallel to L3 and L3 is parallel to L1, which implies L1, L3 belongs to R and L3, L1 belongs to R. Hence, we can say the relation R is symmetric. So, our fourth observation is, again L1, L2 and L3 are three lines and we observe that L1 is parallel to L2, L2 is parallel to L3 and L1 is parallel to L3. Therefore, L1, L2 belongs to R and L2, L3 belongs to R, that is relation R. Therefore, it implies that L1, L3 belong to R. Hence, the relation R is transitive. Hence, the relation R equals to L, M such that L is parallel to M is reflexive, symmetric, and transitive. So R is an equivalence relation verified. Since the relation R L M such that L is the relation R L comma M such that L is parallel to M is reflexive, symmetric and transitive, so we can say that R is an equivalence relation.